Hello, 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 and welcome back to Shiksha Costa. Today we're going to learn how to sketch a graph of a sinusoidal function, especially when we are only given the equation of that function. So by the end of this, you'll be able to sketch graphs of these forms by applying transformations to the original function, f of x sine x. And then you'll be able to also state the domain and range of those functions. To start off, which of the following? So there's a whole bunch of things that we have looked at throughout this unit. We've learned terms like amplitude, and we've learned earlier terms like range. We've also looked at functions being transformed with a shift or a compression. We've learned terms like a single period. We've looked at diagrams of, the radius of a circle rotating around. We've looked at graphs of sinusoidal functions. Looking at all of these things all together, which do you think are related to the changing the value of A in this equation? So if we only looked at this number here and we made it bigger or smaller, and in other words, just changed its value, which of these things do you think would be impacted by that? What about K? What about C? What about D? So there are four different parameters that we're going to be exploring today to find out what are all the connections that relate back to that number in the function. So I'll invite you right now to pause the video here and look at take as much time as you need to connect as many of these as possible to each of these four values. Hopefully you got a chance to do that. Now let's take a look at the value C. So this number at the end here. We know that when we change that value, that what must have happened is the circle no longer has its center at 0. Now its center maybe has moved up. That's what causes us to have to add a number at the end here after the sine function has been applied. And we know that the graph of that looks like it got shifted up a little bit if the circle was moved up. But what if the properties of a sinusoidal function changed here? Well, for one, the midline, which used to be at 0, is no longer at 0. Now, in this example, it's at 2. This was a vertical shift up by 2 units. So not only did that change the midline, but the highest point on the function, the maximum, is now at 3 with the minimum at 1. And therefore, the range of this function, which includes the minimum and maximum, is from 1 to 3. So one of the things to know is that this C value here tells us the exact location of the midline. The midline of this function is always at y equals whatever this number is. But the maximum and minimum, and therefore the range, aren't entirely dependent on C. Notice that even if the midline was right here, if the amplitude was more or less than 1, the maximum or minimum would not be at 3 and 1, respectively. It might be higher, it might be lower. So in order for us to find the range, not only do we need to know where the midline is, but we need the amplitude as well. Fortunately, if we look at the value A in this function, we know that the value A does change the amplitude. And in a diagram, that would involve the circle getting bigger. So the radius of this circle that is rotating usually tells us the value of A here, and changing this value changes the amplitude of the function. Now that changes a number of things. Not only does it change the amplitude, but if the amplitude gets larger, the maximum gets higher and the minimum gets lower. And therefore, those two things, which the range relies on, will directly impact that range. The A value does, as we know, a vertical stretch or a compression or a reflection. And to sum it all up, basically what this means is when we change A, we change the amplitude. So to find the amplitude of a sinusoidal function, all we have to do is take the A value, whatever number that is being multiplied by sine, and make it into a positive number because the amplitude is always expressed positively. And once we know that, okay, if the midline is at C, that's the midline right there, and I can go down by the amplitude, whatever the positive value of A is, that will take me to the minimum point. So to reach the minimum point or to calculate it just from the equation, I can take C and I can subtract the positive value of A. So this symbol right here, these two straight lines, what that means is it's something called the absolute value, which means whatever number is in here, we're just going to make it positive. I don't care if it's negative or positive. If it's positive, we're going to keep it that way. If it's negative, I'm going to make it positive. So C, which is the midline, minus the amplitude gets me the minimum. And to find the maximum, I start at the midline, that's C, and I go up by the amplitude, and that takes me to the maximum value. Now let's check out changing D. So as we saw, changing D involves sort of starting at a different point in the rotation. And on a graph, that might involve a horizontal shift. Now that could be left, it could be right. It depends on what the value of D is. But whatever it is, because we've shifted the function left or right, the starting point of the period now has changed as well. For example, here, if we start at a 90-degree rotation already, then the start of the period ends up being all the way over here. So it got shifted to the left. And so to find the starting point of the period of this function, this fully transformed function, all we have to do is look at what is the D value here? Now keep in mind this is x minus D. So if you see x plus 45 degrees, that means that D is actually negative 45 degrees. X minus negative 45 would have gotten us x plus 45. And that just tells us where the starting value is. Notice the orange graph that you see here is f of x equals sine x minus 90. Sine x plus 90. So this is x plus 90, which means the value of D is negative 90, which is exactly where that function is starting. Now, if we want to know where the function is ending, it looks like it ends at 270, but that's only because we have not changed the period of this function. However, as we'll soon see, to find the actual endpoint, we need to know how long a period actually is. And the thing, of course, that changes the period is the k value. We saw that changing k horizontally compresses a function, or it stretches it if it's a bigger number, if it's a smaller number, or it might even reflect it horizontally. And any of those things will change the length of one period. Notice that this circle is rotating 3 times as fast as this, so k is 3. And that made our period only 120 degrees. That's 360, which it used to be, divided by 3 because it's rotating 3 times as fast. And so to find the period of a function, it's actually quite easy. All we do is take 360 degrees and divide it by k. So if this was sine of 3x, k would be 3, and 360 divided by 3 is exactly 120, and that's the period of this function right here. Now, of course, we always express the period positively. So again, we'll take this number and we'll take the absolute value of it to make it positive. That allows us to find the endpoint. Remember, D tells us exactly where the function starts. If we know how long one period is, we can just take the starting point, in this case it would be 0, and add one period, add p. 0 plus 120 would get us to 120. So that is the end point of one full cycle. That's more or less all there is to sketching graphs of sinusoidal functions. If you have a function that looks like it's in this format, well, that you can start off by knowing that the midline is at y equals c. The amplitude is the absolute value of a. Now we can go down from the midline, going down by the amplitude, or starting with c and subtracting the absolute value of a will tell you the minimum, and going up, or in other words, adding, will tell you the maximum. Now, if you know the minimum and the maximum, that tells you the range. The range of the function is f of x such that this right here, this is our minimum, is less than f of x, and f of x is less than or equal to the maximum value. And again, as long as it's any real number. So we can very easily find the range without ever graphing the function, just by looking at the equation. The period of the function is quite easy to find, just 360 divided by the absolute value of k. The starting point for a period, like we said, is just this number right here, d. And the end point happens one period later. So we just start with d and we add p. Remember, we calculate p just by doing 360 degrees divided by the absolute value of k. Now that you know the starting and the end point of one period, that's kind of like the domain of one period. You already know the range. And so to sketch a sinusoidal function, you can use these to sketch a little box using the domain of one period and the range. And then every sinusoidal function has 5 key points, and then just connect the dots from there. Now, the thing to note is that if a is a negative number, remember, if a is less than 0, then the graph is upside down because there was a vertical reflection. So that's the only thing to keep in mind here. In this example, we're going to sketch the graph of f of x equals negative 2 times sine of 2 times x minus 90 degrees, all adding 4 at the end. I'll invite you to pause the video here and see if you can find the midline, the amplitude, the period, and the starting point of this function, and that'll be a really good start. If you can go ahead and sketch the graph from there, that would be even better. So pause the video here and go ahead and try to do those things. All right, well, hopefully you saw that for this function, this number at the end is a good place to start. That would tell us the midline. So if I have a Cartesian coordinate plane or a set of axes just like this, the midline is at y equals 4. Now, it's really hard to know exactly what these numbers will end up being. I know that I put this out here first, but it would always be better to actually find all of these values first, I think, and that way you know exactly what your scale on your x and y axis need to be. Now in this case, because the midline is at y equals 4, that would look something like this. And the amplitude is the next thing I'm going to look for because I want to know how high or low do I go from this number right here. And because the amplitude is the positive version of whatever this number in front here is, the amplitude I can see is 2, and that tells me the maximum and the minimum. So from 4, I could go up by the amplitude. I could go up by 2, and that tells me the maximum. And from 4, I could also go down by 2, and that would tell me the minimum. So my function needs to be in between these two lines right here. In other words, the range of my function is f of x such that 2 is less than or equal to f of x, which is less than or equal to the maximum value, which is 6. And it can be any real number in between there. Now let's take a look at the domain of one period. So the period in this case is always found by 360 degrees divided by k. So divided by 2 is 180. And this function's starting point is whatever the d value is. So over here, we can see the d value is positive 90, not negative. Remember, this is x minus d. This is actually the d value is positive 90, which would be right over here. And then one period later, if I add 180 degrees, one period later would land me at 270 degrees. And that's the end of one period. So it starts here, it ends here. This is the lowest it gets, and this is the highest it gets. And so that tells me the domain of just one period is x, such that x is between 90 and 270 degrees. Now that box that I made in the center here, my sine wave has to fit in this box. It has to reach the maximum, it has to reach the minimum. This is the midline. But the last thing, before I can start to sketch it, I have to look at the a value. Now, because this is a negative number, because it's less than 0, the sine wave is actually upside down. So normally it starts right here on the midline, and it starts by increasing. But because this is upside down, it actually goes down from the midline, and then it goes back up. And I can just connect these dots to make a wonderful sine wave. And that's how you sketch a sinusoidal function, folks. You start with the midline, then you use the amplitude to go up and down. You use the starting point, which is d, and the period to find the range. And then using that, you can make that little box just like you see here. You plot your 5 key points upside down if the a value is negative, and then you just connect those dots with a nice smooth curve. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.